Hello. Thank
Hi.
you. How was your guys' day so far?
I think really good so far. There's a heat wave in Finland, but we're doing okay.
Oh,
Yeah,
how
but
hot is it?
I think it's around 30. Not so bad, I think, globally, but for Finland, it's really, really, really bad.
Yeah, if you're not used to it, it definitely makes a big difference.
Yeah. But yeah, very much a welcome. I think we're all very excited for your session. So the stage will be all yours for the next 30 minutes.
Awesome. Thank you. Okay, so I'm Karin Wolok. I work with Neo4j. It is a graph database company. And I'm going to talk to you a little bit about graph databases and what they are. And if you haven't heard about graph databases, or you've heard a little bit about it, but you don't really understand what it is, you're in for a treat. If you have, then some of this might be slightly redundant to you. um, but let's see. I'm just going to make sure that my screen is being shared. Can you guys see my screen? Just want to confirm.
We can see your screen. All perfect.
Okay,
Thank you.
great. Thank you. Okay, so let's start here. Okay, so in this presentation, I'm going to go over why graphs, the use cases, the data modeling, querying the graph, and Neo4j. So I'm just going to start off with the very, very basics. Why graphs? Talk a little bit about what graphs are, just in case you're not familiar, because a lot of people think I'm referring to charts when I'm talking about graphs. I'm not referring to charts. When I'm referring to graphs, I'm referring to the graph theory graphs. So just a little bit of history and background. This gentleman right here, his name is Leonhard Euler. Leonhard Euler is a Swiss mathematician who was born in the 1700s, and he is the inventor of graph theory. So basically where graph theory kind of initially came to play is there was a, oh, it looks like this image is underneath, it's hidden, but we'll go with the image up top. Okay, so in Königsberg, Germany, there were surrounding lands with two kind of floating islands in between this big body of land. And in between these islands and the main land, there were 7 bridges. And Leonard decided to try to see if it was possible to start in one location, cross each bridge once and only once, and get back to his original starting point. And the way he kind of tackled this problem is he drew out a graph. So for the land masses, he represented them as dots, which are, in this case, well, I'll get in there too, but it's like nodes and it's like edges and vertexes, right? So the dots represent the land masses and the lines in between those dots represent the bridges. And he actually, it's pretty simple approach. He basically just traced his pencil around the graph, trying to hit each dot without repeating the same line. And then they came up with a formula for it. And that's called the if it is possible to cross each bridge once and only once, or not be able to run over the same path again, then it does follow what's now known as the Eulerian circuit. In the case of Königsberg, Germany, it did not follow the Eulerian circuit, so it wasn't possible to do that. But this is the concept of a graph. So a graph is basically made up of edges and vertexes, complexly connected things. So why graphs? This is actually how I see the world. So this is kind of why I fell in love with graphs. Everything in our world is connected. People, places, things. There's always some other kind of context that is related to something else. And this is where graphs become really powerful. So being able to see how things are connected or related, or finding patterns in things. That's when the modeling data and graphs can be pretty groundbreaking. So this is kind of just mentioned, going back over it. You might already be thinking about like, oh, all the different things that are connected, like if you think about sciences, technology, networks, machines, computers, how we connect to each other, everything is connected. And I will get into actually a couple use cases where I'll demo some of the product itself too. Now with relationships too, is that this is another thing where with Neo4j, being a graph database, is we put a lot of value and emphasis on the relationships between this connected data, which I will get into next. So Neo4j, what is a graph database? So now that you know what a graph is, Neo4j is a native, ACID-compliant, schema-free, transactional database. So one thing that I feel like gets lost somewhere in translation is that it is a database. Technically, it falls into the NoSQL category, but it's very different from NoSQL, but in the sense that it allows you to model your data in the shape of a graph, like a network, rather than tables with joins. Now, what makes Neo4j very unique is you have the ability to model your data as a graph, store your data as a graph, and query your data as a graph. So this is something I think is pretty important to note when you are storing the data. So I'm going to actually go into like the kind of unique differentiators on why having a native graph database is so much different from any other relational type of database that you may have encountered. So first, let's talk about the storage of the data. So most normalized relational databases, I mean, as you probably already know, if you have the opportunity to work with them, they are database, a bunch of tables that are connected with joins, right? And when you are querying this data, you have to make a hop and then you're indexing, and another hop and you're indexing. And when you're making a lot of hops, that ends up being very computationally time consuming and also very expensive because of that as well. So Neo4j is actually built to support the graph model, the shape of the data, to be able to make a lot of hops when you're doing queries. So basically, when you're querying this graph, like even though it's a beautiful visualization, the UI is very nice, the way it's stored is very different. So when you query this graph, you actually find your initial starting point, the first node, and from there, you're basically just chasing around memory pointers. So the benefit of that is that you can do 1 hop or 12 hops inside of the graph, and the traversal time stays pretty consistent because the computer happens to be pretty good at chasing memory pointers. So that's one thing that's really valuable, is that you have the ability to make these very long hops out, friend of a friend of a friend of a friend, those types of things, which when you're talking about graph algorithms and doing network type of analysis, that's when it becomes really, really powerful to have that type of underlying architecture. So property graph model components. So when you're talking about graph database, the data model is composed of nodes that are represented as circles. And these are your nouns. They're person, place, thing, location, anything that is a thing, right? Now, the relationships between those nodes are generally, the nodes also can have properties. So you can put properties inside of those nodes describing who they are, what they are. You can have different types of nodes as well. So you can have a people node, you can have a car node or whatever. So you can have different types of nodes, different types of people, and then they also have properties inside of them. And then those relationships between them, the relationships generally are directional in Neo4j. And these relationships, let's see, yes. So they are directional. You can make them go both ways. You can also traverse the graph backwards and things like that, which I'll kind of get into a little bit. But these directional relationships, you have the ability to also have different types of relationships. You can put properties on there, geospatial information, date and time. These relationships can have values. So maybe Dan really, really loves Anne, but Anne only loves Dan a little bit. These values come into play of like, how are these things connected and how are they related? So in Neo4j, relationships are first-class citizens. So they're almost treated just as important as the nodes themselves. It's not just the nodes, but it's how are these things connected and the intricacy of these relationships. And that's when it becomes really, really powerful. Super cool. So the other part about Neo4j, when you're using graph databases in general, is the query language. So most relational databases, you're probably very familiar with SQL. they use SQL. SQL is great for what it does. SQL is not great for working with graph type data. So Neo4j actually developed the language. It's an open language and it's used by a lot of organizations around the world. The language is called Cypher. Cypher is basically like SQL for graphs. It differs in the sense of SQL is very much like, give me this, and Cypher is more about pattern matching and complex connections and clustering and all that kind of stuff. So that's where it's really, really powerful, is that doing this network type of analysis. And I'll give you some examples, dig into this a little bit, because it's pretty cool. So Neo4j is, Cypher is it's a declarative language that's built off of ASCII art. So it's actually meant to look like what it represents. So your nodes are represented in parentheses, just as you see here, match person Dan inside parentheses. And then the relationship is actually brackets with an arrow. It's pretty straightforward, actually. It's kind of easy to see and understand. Like, even if I just go back here, you could see the U is a node. The relationship is in brackets with an arrow to another node. So you're literally just forming sentences. So yeah, so these are your labels and your properties, but this is like kind of the basics of Cypher. It's actually like a really beautiful query language, I think. So here's an example of a query. I pulled this from a blog post. It's like a Neo4j recommendation blog post. And I really like this blog post because I think it shows a lot of not only the values of modeling your data in graph, but as a graph, but also to be able to query it in graph and how powerful that can be. So this is an example of a query where you are looking, I don't know if you're able to see that, it's pretty small, but it's electronic arts is in the middle there, and you're looking for, so their query up top is, I'm looking for a company, which is in your parentheses, and you have develops in brackets with an arrow. So a company that has a relationship that's developed to a game. And then you also have a relationship coming in from the other direction as well. So you have company that publishes a game, if you're able to see that. So you're basically looking for a, where the company is Electronic Arts is below next line, right? So you're looking for a company that develops and publishes a game where the company is Electronic Arts. So this is the type of queries that you could do that are like, with the pattern matching kind of thing. That's very straightforward. Here's another example that I really love this one because I think this kind of shows the power of graphs, and it also gives you the ability to understand like how it really differentiates and why it's necessary to use a different query language when you're doing connected data type of queries. So in this example, the two yellow nodes that you have here is you have Fallout 3 and then you have Borderlands 2. And then around these yellow nodes with these relationships between them are, you have maybe in blue is like the different consoles that they might be played on. In green is like the different themes of these games. So planes and war and pirates or whatever. Now, as you can remember, the relationships can also be weighted. You can put property and values on those relationships. So you can also consider the fact that this has a lot of planes and a little bit of zombies or whatever. And that you can also calculate those things on, impact of like how highly related they are, not just the shared characteristics. And then in red, you might have like, how is the game played? Is it first person? Are you playing with a mouse or a joystick or a keyboard? Now, if you have a user that likes both of these games and you wanted to say, or you wanted to ask, okay, what do these two games have in common? I just want to know what their shared characteristics are. So normally, if you were using SQL for this would be a pretty extensive query because you have all these different kinds of nodes and different types of relationships. And also just constantly indexing. You can imagine what doing this type of query would take. And with Neo, that's what your query would look like. Oh, actually, there is a little bracket missing in between those two dashes. But so the bracket is missing in between there, but it's supposed to be the relationship in either direction. So it doesn't actually have an arrow, but you can have the game with relationship to a characteristic, any relationship, any direction between these two games. And then you can make that comparison to 200 other games and say, find me another game that has the most in common with these two other games. And if you think about how much of an impact that would make on your recommendation, that's when you really kind of are able to see the power of it. So I think it is important. Graphs are super cool. I am slightly obsessed with them. I love talking about it. I will nerd out about it all day. But it is important that you are using it for the right use case. Graph databases are built for highly connected data problems. If you're going to whiteboard and you're drawing out your data model and it looks like a graph, it probably is a graph. If it's not, don't try to stick it where it doesn't work. I'm sure I don't need to tell you that, but I've heard this before where people were super excited about graphs. They just stuck it in places that it doesn't belong and it doesn't perform well because it's not built for that. So we do have some books, if you guys are interested, graph algorithms that, well, it gets really nerdy into like all kinds of network analysis and centrality and PageRank and all these, we have graph algorithms libraries and stuff like that too. They're cool. So I'm going to give a little bit of a review. Actually, I'm going to show you. So here's where you can get started, but I'm going to actually give a little live demo with the sandbox. So we have a sandbox. It's basically an area where you can just go, you can play around with pre-existing data sets with like queries that are already built in for you to just walk through. You don't have to download anything. You don't have to do anything. It's a really great place to start because it kind of gives you the idea of like what kind of things you can actually do with your data, like get you start thinking graphs. Let me see. Okay, so I'm just gonna, let's see, I'm gonna exit this and I'm gonna go here. So I already have a sandbox open. Okay, so this is kind of squished. So I'm gonna see if I can move this over. Sorry. Okay, yeah, that's good. Sorry, I have a split screen open, so I'm like hoping that it's not as squished as like what it looks like here. Okay, so I'm gonna review it's like a criminal investigation use case. I just wanna check my time. Okay, perfect. Okay, so it's a criminal investigations use case. And in this case, like our basic data model is we have 4 different types of nodes. We have persons, which are victims, suspects, witnesses, investigators. We have objects. These are documents, evidence, weapons, vehicles, locations, crime scenes, home addresses, places of employment, public buildings, things like that. And then we have events, which are the crimes, phone calls, meetings, arrests, et cetera, et cetera. And actually, this data set was taken from a public data set, but there was only partial parts of the data. I think it was anonymized already. Let me see if I have it in here. It's let's see. I'm seeing if this has the. Yeah, so this was taken from crime data from Greater Manchester in 2007, but not all the data was filled in here. So the stuff you're going to see is there's fictitious names in here just to kind of provide you the ability to play around with the data. But there is some of the data that is actually slightly accurate but anonymized and stuff like that. So, but this is it's a fictitious data set. Okay, so I'm just gonna show you like the basic database schema here. So let's see. Okay, so here are the different kinds of nodes that you have here at the top, different labels of nodes. So you have vehicles, areas, they're represented by colors. You have the crime, the person. These things here are basically relationships from person to person. So there's a couple different types of relationships here. This one is, so as you can see on the bottom of the display right here, is you actually have information about the person. So you have like it shows you like the properties and everything inside of each node. So in the relationships here is, here it's No's phone. If you can look right below the display, family relative. So No's phone means that they have communicated via phone or something like that. No's social network, they're connected via social network. Person knows a person, and this one is living with, if a person lives with another person. And then you also have the ability to see their current address and all that kind of stuff. So this is kind of like the basic schema. And Neo4j is schema free, so which is also very nice. Very nice. So I'm just going to do a couple queries here that are just pulled directly from Sandbox. So here is, you're able to just literally see the amount of crimes, and you can have the results given to you by the places that are have the highest crime rates. So Piccadilly train station, highest crime rates versus addresses or something like that might have a little bit less. So this is just a very basic query. And let's see, shortest path between people, investigate. Okay, so we'll start right here. Let's see. Okay, so actually you can do queries like this, for example. So this is with a distance, so it's based off of latitude, longitude properties for the nodes. But if you're looking, for example, a crime that has been committed within 500 meters of an address, let's see if I have this in here. Yeah, so let's see. Let's just say 1 Corona Street. Yeah, okay. Yeah, so this is like, these are crimes that have been committed within 500 meters of this address. Now here is like, so you have a Detective Larive, and we're gonna run a query on him. We're gonna try to see what crimes he investigated. And then it gives you this result. So here is our detective. As you can see, the properties are on the bottom, who he is, his rank, his surname. And then you could see the different crimes that have been investigated, and the locations of where they were. And you can kind of play around with this data set, which is also kind of nice. It's a visual representation where you can kind of just play with it. There is also a lot of different visualizations that you can put on top of your graph to be able to do more type of visual analysis. So yeah, there's different areas and postal code just to give you a little bit more depth in terms of the location. And let's see. So sorry, I'm getting distracted here with stuff. Okay, shortest path between people. So in this query here, we are looking for a crime that has been, let me see, this query here. So it's a crime that is under investigation, being, let's see, being investigated by an officer with this badge number, and the people who are related to other people that this person is investigating. So this is basically where you can start. Let me see, this is not the right query for that, but that's okay. So you also have the ability to do some graph algorithms on top of your graph database, which is really cool. You could do things like community detection, basically seeing things that are highly connected to each other. You have the ability to do shortest paths. So like, let me see this one. So this is all pulled from Sandbox. You can literally go to these guides and walk through one by one. It gives you like the different examples of the different types of queries you can do and what type of results you get, and then kind of digging into it a little bit more. But it gets really very interesting. So let's see. So this is you're doing an officer that investigated a crime related to drugs, and the person who knows another person who is related to that crime, right? So sometimes if you're talking about like things that are like fraud rings or criminal investigation and things like that, these relationships between people provide a lot of insight that can help you identify if there is like a gang, for example, or if you're looking for a fraud ring. You know, sometimes those things are distantly connected. People use graphs for all kinds of things. I think this is a pretty good use case, just generally speaking, because you know, a lot of people can kind of visualize how these things are all intertwined and connected. But there are people who use it for like network and IT management. You know, they have their different systems set up and how and dependency graphs. So if something goes down, what other things might be distantly connected that might be impacted by it? Or if you're looking for, people use it for knowledge graphs, you might have heard of too. So like NASA, for example, builds their lessons learned database, like their knowledge graph, using Neo4j. They basically take 50 years of unstructured data, they clean it, put it into a graph and do some topic extraction. There's a lot of it. Actually, if you're interested in that use case, you can just type in NASA Neo4j and read all about it. It's really cool. But So they are able to surface. So when someone does searches or like is looking for something that's similar to what they're doing, they're able to search for the most relevant information on for this 50 years historical data that they have. Recommendations engines, as you saw in the last example, are also very popular. And then there's also the crime investigations and a lot of social graphs, page ranks. Those things are also built off of graphs. So there are some really cool, interesting ones in here. So let me see if this is, so let's see if there was one where community. So this is where you kind of go into graph algorithms, just checking my time. Second. All right. Okay, I have less than 5 minutes. So, okay. So, so the graph algorithms, we actually have a graph algorithm library that has like something like 50 different graph algorithms that you can run on top of your data. It gets really cool. There's also a graph algorithms book that is available for free download, which I showed before. But so when you're looking for triangles, what that basically means is one person is connected to another person that's connected to another person. It's literally creating a triangle between their relationships. And based on how many triangles a person is actually involved in can actually kind of show you how important they are inside of this graph. So, whoops, lost it. Okay. So here is the people who are part of the most triangles, that they're probably very, very important people inside of the graph because they're like highly connected and intertwined in this, crazy madness of connections. Then there's also, so if we're looking at this kind of stuff, let's see. So this is one where we are looking for triangles that this, let me see, I think it's a person is connected to a crime. Yeah, let's see, where they have the triangle around Philip Williamson. So Philip Williamson, and here are the triangles that he's part of, right? As you can see, he knows Kathleen and Raymond. They all know each other. Here's another triangle. And this is where it starts to get really kind of crazy. And in the crimes that they're involved in. So Philip, in some cases, you could say that Philip is kind of, well, he's a highly connected person inside of the graph. So these are like the community detection type of algorithms that you can run. There's also something else that was really cool in here that I'm going to see if, this one. So this is we're calling it dangerous friends. Basically, we're looking for people who know somebody who is connected to a crime, who's affiliated with a crime, but they themselves are not. So this is where the person is not involved or associated with a crime themselves. So this will give you a list of these people who might be more likely to be involved in crimes, or they have a lot of criminal activity around them, but them necessarily aren't. In a lot of cases, this might represent children or something along those lines. And then you can even dig out a little further where you can see friends of friends that are connected to crimes where the other person's not connected, and all that kind of stuff. It's pretty cool. Okay, I have like 2 minutes left. So let's see. So what else do we have? Okay, so this is betweenness centrality. So this is another type of algorithm that you can run. Betweenness centrality is basically shortest paths inside of, like, you're looking for a node that's most closely connected to all the pieces inside of your graph. So it really kind of just gives you what they call like a pivotal node. So it's a node that is most highly connected to either the communities or like all the nodes in general, like your total graph connection. So Annie Duncan is one of our most connected people, which is crazy. What I would say is that if this is something that sounds interesting to you and you're interested in exploring connected data nests, or you have a data problem that looks like a graph or feels like a graph, or you want to be able to do queries that are graph-like and network analysis type of stuff, this might be something that you should look into. Like I said, great place to start is the Neo4j sandbox. And you can also download Neo4j when you're ready to get started and put in your own data. And we have guides and walkthroughs and training materials, and it is open source, so you can go ahead and play with it. And yeah, that's that's what a graph database is. And I hope you fall into the graph epiphany like I did. Thank you.
Karin, thank you so much.
Yeah.
Thank you for your time and for your presentation, and especially for your very informative demos. It's a pleasure to hear you speak. You're so passionate and knowledgeable. So thank you very much for being with us today, and we hope you stay safe and you stay healthy.
Thank you. I really appreciate the time. I'm very addicted to graphs. It's like everything I see is networks all the time.
Yeah.
It's all connected. You're like, oh my God, I could see how you can ask all these things. I heard this one really interesting use cases. There was a woman who was like, patterns of how we eat and what other things impact our lives that make us make these types of decisions. And if you do this, it gets pretty crazy. So.
Well, it is true that everything is connected, right? So.
It gets even crazier once you have the ability to like really dig into it. You're like, I didn't even know, because that's one of the things with graphs is that you have the ability to see things that you didn't even know were a factor until you're able to query it that way. So.
Wonderful. Thank you so much, Karin. We're going to move on to our next session, and we'll be looking forward to staying in touch.
Yeah, thank you.
See you. Bye.